In this tutorial, we will be creating volumetric liquids effect by using fluid simulation. First of all, we need to create an arbitrary object and change its position to your liking. Now we have to turn this geometry into a volumetric by applying fluid source node and change its initialize type to source flip. We can use the same node with initialize type set to a collision in order to use another geometry as a collider object. It is advisable to connect both of these nodes to the null object with an appropriate name. Dynamic forces can be created by applying .network node. First of all, we need to apply flip solver in order to simulate fluid effects. Next, we have to create flip object and connect its output to the first input of a newly created solver. Simply remove a built-in fluid object and specify your own fluid source by applying source volume node. Change its initialize type to source flip and place previously created fluid object into its volume path. Create a duplicate of this node in order to import collider object to our dynamics network. We are able to create virtual boundaries for our fluids by enabling close boundaries option and decreasing an overall size of a fluid container. It is worth mentioning that Houdini automatically removes some particles because of the enabled reseeding option. We can simply bypass this behavior by increasing its depth threshold. Now we need to apply gravity force in order to add some motion to these particles. Source volume generates new particles on each frame. We have to restrict its activation period only to the first few frames. Stop animation on frame 10. Hold down a control key and click on activation value in order to define a new keyframe. Go to next frame, decrease and activation value down to 0, and create another keyframe. Now we need to decrease a particle separation value in order to improve an overall quality of our simulation. Its effect will not take place unless you will copy this value and pass to the fluid source. In the final part of this tutorial, we will retrieve information from our particles by utilizing .io node. Drag and drop .net1 into the .network field and use the flip object as the .node. Increase the number of fields up to 1 in order to import previously created particles into the SOP network. Now we have to convert these particles into a volumetric object. The volumetric effect will not take place unless you will decrease its minimum radius. Overall quality will be improved by decreasing its voxel size. Currently, a volumetric object is barely visible. This problem can be easily solved by utilizing a combine node. Simply increase first multiplier value in order to expose more details of our volumetric. Eventually, we are able to render this animation in the flipbook in order to see the final result of our simulation.